just need to remind everyone that you need to go over your quadrilaterals. Remember, you were taught quads from grade 8 or 9, right? Your rhombus, your palm, your rectangle, your square, your kite, and your trapezium. You need to know those 6 quads and their properties.
There's no formula for distance, like if they have to calculate the area.
Yes. You need also to know, listen, you also need to know how to calculate the areas of those quads. Now, why am I saying this? Even if you don't get a question on area in the upcoming June exam, but in your final exam at the end of the year, you are expected to know the properties of quads together with the formula to calculate their areas and their perimeters. Okay? Okay, so let's come to that now. So yesterday, we stopped here and we said the shape we have here is a rhombus. Since it's a rhombus, the 4 sides are what? Are equal. Therefore, if we are to calculate the perimeter, we just have to determine the distance of one side. Then we multiply it by what? 4. So it's very straightforward. Okay, it's not complicated. So for 4.1, right, based on the information that we have AD, okay, we are given the coordinates of A and the coordinates of D. So it will be better here to use the coordinates of A and D to calculate the length of AD. Then we multiply that length by 4. Then we would have answered the what? The question. Okay, so for 4.1, first thing I'm going to say AD is equal to the square root of XA minus XD squared plus YA minus YD squared. Okay, then I'm going to have AD equal to the square root of XA, which is minus 8, XD, that's a 3, and then YA, that's, okay, so I have minus 8 minus 3, then YA is 6 minus YD, that's a 9. So what am I doing? Finding the distance. This is pretty straightforward. Okay, so this will be the square root of minus 11 squared plus minus 3 squared. So we get the square root of 121 plus 9, and that will give us the square root of 130. Okay, now can the square root of 130 be simplified? No. So we leave it as it is. Okay, then our perimeter, so perimeter, yes?
I wonder if you continue to like simplify it.
Simplify square root of 130 to what?
Not simplify it, convert it to this.
No, there's no need for that. Okay, please be aware that you are in grade 11. You did rationalization, isn't it? You did sets in this grade. This question says, leave your answer in simplest set form. No need to convert that to a decimal. Okay? Even if it was not specified, you can leave your answer in set form. Okay? But if the question specifies that round off answer to 2 decimal places or 1 decimal place, then you can do the conversion. But this question now requires you to leave your answer in set form. So you can't convert that to a decimal. So, perimeter of ABCD is going to be equal to 4 times square root of 130. And this will give us 4 root of 130 units. Okay, you just stop there. Yes? You can be penalized for not following an instruction. Okay? Because you need to follow this instruction. Follow that instruction. Yes, because it's perimeter, it has got units. In this case, you are dealing with a Cartesian plane, so you have to write units. But as teachers, if you don't write units, we don't penalize you for not writing units. Because that's not what we are testing. We are testing here whether you know how to determine the perimeter of a rhombus. Even at metric levels, well, the units part is not that critical, but you should know that you are dealing with distance. Let me put that away, please. Okay. Next question. Next question there. Calculate the perimeter, determine the equation of the diagonal of AC in the form y equal to mx plus c. Okay? Determine the equation of a diagonal. Determine the equation of a diagonal AC in the form y equal to mx plus c. Right? Now we want to find the what? The equation. And here, in what form? A what? A straight line. If you want to calculate a straight line, what are you supposed to have first in order to determine the equation of a straight line?
The gradient.
The what? The gradient. So, based on the question, do we have the gradient of AC?
We can work it out.
Huh?
We can work it out.
Okay, but what are we given? We are given the gradient of what? The equation for what? For BD. Right? Now, what do you know about the properties of the diagonals of a rhombus?
They are actually bisected 90 degrees.
They bisect at what? 90 degrees. They bisect at 90 degrees. And the diagonals are not equal. I hope you know that. They are not equal in length, but they bisect each other at what? 90 degrees, which means the diagonals are perpendicular to each other. So, for 4.2, so first thing that you have to do, write the equation for BD is 3x minus y equal to 0. Then you rewrite this equation in standard form to determine the gradient. So this will be the same as 3x equal to y, which is the same as y equal to 3x. So here, the gradient of BD is going to be a 3. The gradient of BD is a 3. Okay? It's positive. The line is slanting to the right. Therefore, the gradient of BD is a positive. The gradient of AC is a negative. Okay? Yes.
The gradient of BD is not the negative of AC.
Okay, be very careful. Let's go back to the standard form. Our equation given is 3x equal to 3x minus y equal to 0, right? You take the minus y to the what? To the, or if you don't want that, you can take the positive 3x to the right. It becomes negative what? 3x. But on the left, you'll be left with minus 1. So how do you make the coefficient of y positive? You divide both sides by negative 1. So you come to this. You come to this. Can you stop talking? You will come to that. Right? Do you have a y-intercept? Huh? Okay, but I'm saying based on this equation, do you have a y-intercept? No. That's the gradient 3. Isn't it? Right? Then, to get the gradient of AC, we say MBD times MAC is equal to minus 1. That one is equal to 3 times MAC is equal to minus 1. So MAC is going to be negative 30.
Yes. You know what the gradient, if you know 1, can you not just go straight to MAC as minus 1?
Okay, I don't encourage you to do that. You need to go via that route. Because a mark can be allocated here for the determination of the gradient of AC. In actual fact, one of the marks there is a gradient for AC. How did you get it?
So you just flip it.
Right? Show us. Don't just flip. Say flip. That's not math. Flipping is not math. Okay? He is a true mathematician. Okay? Okay? Why is that the case? Because BD is perpendicular to AC. Okay? Then once I have that, it's easy now to find the equation for what? For AC. I'm going to use the coordinates of A. Right? By the way, I think this will be my first time to find the equation of a straight line in this class. Yeah, because I don't think I did the question on finding the what? Equation of a straight line. Okay. In this class.
You did it last lesson.
Did I do it in the last lesson?
Yeah.
It wasn't the same question. It was not the same.
Okay, right. So, over the years, okay, when you're finding the equation of a straight line, it's so easy. Remember, it's a grade 8 concept. Do you know that? Sorry, grade 9 concept. Right? So, right, y equals mx plus c. Okay, we can find our y-intercept first. Okay, if you want, you can use m equal to y minus y1 over x minus x1, and then you carry on. Right? But I realize that one is wrong. Don't want that. Let me do it this way. So y is 6. Our gradient is minus a third. X is minus 8. So this will give us 6 equal to 8 over 3 plus c. Then you simplify this. Right? You take the 8 over 3 to the left. So you get c equal to 6 minus 8 over 3. And this will give me c equal to, now this is the same as 18 over 3. So 18 minus 8, I'll get 10. That's 10 over 3. Okay? By the way, this is not my answer. Therefore, my equation, which you are supposed to determine, is y equal to mx, so that will be minus a third x plus 10 over 3. Yes.
If you round it, it's not.
This is analytical geometry. Avoid working with decimals.
I did it where I calculated the angle of deviation of dB.
Okay, of BD, this one, you calculate this angle here.
Yes.
And then?
So I calculated that angle and I used angles and triangles and find k sigma.
Find what?
I used angles and triangles as k as the angles in also reconstruction that's k over AC is 90.
So you calculate that.
Yes, I calculated that.
If you subtracted this from 180, you got that.
Yes.
Then you use that angle of inclination to calculate the gradient of AC. It's correct. It's correct, but it's a longer method though. But it's fine because that's what came into your mind when you saw the question. So it's fine. There's no problem.
But I rounded it off.
That's the main issue now. Because when you round it off, you might have problems here now. What value of the y-intercept did you get?
I got 3,333.
3,33? 3,333. Yeah, it's the same as 10 over 3. So, but you see, in your case, you work with a decimal, then your answer has to be marked as integers. Okay, it's correct. You must use the correct math concepts. And it's a good thing that you were thinking as well. Right? But I think you're thinking you went too far. Right? But you get your full marks. Okay? So it's fine. Yes? Huh? The what? For the questions, for this question. Okay, let's talk about that now. So the mark allocation, it's 4.2. We have got. Okay, I'll give the mark first for finding the gradient of AC. Okay? That's where I'll give the mark. Then I will also give a mark. Okay, can I have your attention? For substituting the coordinates at A to find, so here substituting what? Minus 8, 9. It's minus 8, 6, right? Minus 8, 6. Okay, so that's your second mark. The final mark obviously will be for the equation. Right? Okay, finding the gradient of BD, it's a very basic thing. So I would give you a mark for knowing that the product of the two gradients is what? Minus 1. For knowing that. Because it's very important for you to be able to get the gradient of what? AC. Okay, some of the simplifications here, they are very basic. So there's no mark. The final answer for the equation. Okay, so if I was the examiner, that part for finding the gradient of AC, I would allocate it 2 marks because that's a very important part. Okay? Are you following? Yes. Okay, so let's get on. Then the next question. Stop here. Okay, so calculate the coordinates of K. Okay, the coordinates of K are actually a midpoint. Okay, calculate the coordinates of K if the equation of AC is equal to that. Now, do you see that this question is easy because we found that equation. Okay, we found it. So if I want to find the coordinates of K, there are 2 ways of finding those coordinates. One, I can use this equation and the equation for BD, which is what I'm going to do, right? Or if you can use the midpoint. So I'm going to use the what? The equation. So the equation for BD is 3x minus y equal to 0. So 3x is equal to y. So I'll call this one here my equation 1. Then the equation for AC is x plus 3y equal to 10. So that's equation 2. Okay? Now we are in grade 10. Simultaneous what? Linear equations. So when there is y here, so I'll say therefore x plus 3 times 3x is equal to 10, and this will give us x plus 9x equal to 10, and you get 10x equal to 10, so x is 1. Okay, therefore y is going to be equal to 3 times 1, which is 3. Therefore, the coordinates of K are x is 1 and y is 3. And then we are done. Okay? And then that's it. You can use the midpoint, but since here they gave us the equation for AC, they are giving you a hint as to which method you can use. But if you calculate the midpoint of K using, okay, do we have the coordinates of C?
No.
Then it means you may have to calculate the coordinates of what? Of C. And use those coordinates together with the coordinates of A to find the midpoint. But that's a longer method though. The one which you have here of equating the 2 equations is the easiest. Okay? Right? Then calculate the coordinates of B. Okay? This is a rhombus. There are 2 methods of finding the coordinates of B. You can use what's called transformation, or you can just use the midpoint itself. So I'm going to use the coordinates of K to find the coordinates of B. Do you know that it's possible to do that? Right, so I'm already smiling. Okay? I'm already smiling because that's easy. Okay, so 4.4, I'm going to write my midpoint. Remember, the formula for the midpoint in this case is going to be this one. So we have x1 plus x2 all over 2, and then y1 plus y2 all over 2. Okay? Now here, we are given the coordinates of the midpoint. So we know the value of x there, it's a 1, and the y is 3. So 1, 3 is going to be equal to x1. Now my x1, I'm going to consider it as the coordinates of D, which is going to be a what? A 3, plus the value of x at B all over 2, right? Then my y value, it's a 9. 9 plus the y value at G all over 2. Now, this one becomes interesting. Do you know that you can equate this 1 to that, and equate that 3 to that?
Yes.
Do you know that? Huh?
Sir,
Yes?
your coordinates for K around 0 and 9.
Yeah, what?
If your coordinates for K around like that.
That would be CA maximum. Okay? So, from here we say 1 is equal to 3 plus xd all over 2. Cross multiply, you get 2 equal to 3 plus xd, and xd is equal to minus 1. Then we have 3 equal to 9 plus yd all over 2. We get 6 equal to 9 plus yd. So yd is going to be minus 3. So the coordinates of D, x is minus 1, y is negative 3. Okay, but I don't understand why they are both negative.
They both is P is nothing for P.
Oh, okay, sorry. It's D. Okay, sorry. I'm supposed to write here D. Okay, just give me a second. This is supposed to be what? B. Alright. So I need to change that to B.
So that says that P is separate.
No, it's supposed to be B. So let's change this to B, please. I put D there by mistake. Okay. Please, it's B.